got today is pretty good stuff. You're going to see it. You know, most people don't like the biostatistics, but I think we can turn it into such a way that it's going to be good. It's going to be something that you can use. And so when you get those questions on your test, you know, you get 44 to 46 per section. And guaranteed 1, 2, 3 questions are going to be biostats. And when you get those, you want them, you know, you want to answer them right away and get your answers right. So here's our goal today. These are the kind of must-knows. I know it's kind of dark now. I don't have to work those lights too much, but you know, we want to accomplish this. Now, if we accomplish this during my time, then it was a success, and I know I did my job to at least present this material. Now, for something that you don't understand when we go over this, you know, I'm here for all today and to tomorrow. It's stop me, please. You know, I've made 2 trips to McDonald's since I've been here. This is the first time stepping into this room from board. So definitely hit me up, and I'm telling you, I can explain this stuff to where you can know it. You know, I got a friend that we study, she studied through step 1, and we get together and I say, hey, don't let's just bust the biostats real fast. And we can pretty much go through, there's 66 questions I believe in that. And we pretty much can go through those and answer them just by a lot of this basic knowledge, okay? So this lecture should be uploaded on the drive. And of course, again, what I like to do is always kind of laminate it. It works for me. You know, do whatever you need to do to get this stuff. All right, so let's begin. Now, does anybody know how to work these? Is there a certain button? This one?
Just push them. I don't know.
Go on, this one. Okay, all right, good deal. All right, so the first thing I'm going to cover this, and we'll go over some questions. That's just kind of how it works, all right? The types of studies, you got to know them, all right? You got to know the types of studies. Now, the 2 big ones, case control and then cohort study, okay? And here's how you're going to understand this. Case control, there's an A and an O, okay, right? A and O. That means the A is going to say someone that has the disease, and the O represents someone who does not, right? So when I say case control, you're thinking, all right, I'm doing a study, and right now that we know somebody has the disease and somebody does not, okay? Now, if you have that, do I really care going down the road looking forward? No, I don't really care what goes on. I already know someone has it, someone doesn't. So what I care about is looking backwards. That's what they call it. So when you say case control, someone's got it, someone doesn't. It's retrospective. Okay, they like to use that word, retrospective. Now you got to make this association too. Case control, odds ratio. Okay, boom, odds ratio. Flat out, it's one of those memorization things. Okay. Now I'm going to tell you about this other one that's a little more. You can make an association. But when I say case control, A and an O, I got the disease and someone doesn't, and then someone decides to do a study about it. Okay, it's retrospective, odds ratio. Okay. The other one is cohort. All right, cohort, 2 O's. Now 2 O's, that represents, well, this person doesn't have the disease, this one doesn't have it either. So nobody's got it. So I can actually look forward, because I want to see what's going to happen. And I can also look back to see, well, what's happened so far, and they still don't have the disease. So in a cohort, no one has it, no one has it, but I'm going to find out if something happens. I can look both ways on that. It's retrospective and prospective. Now cohort, they look the same. Like relatives, right? Relatives, they kind of look the same. Relative risk. Cohort, relative risk. Okay? You got to know that. I've come across a question at one point to where the flat out, all you got to know, they said blah, 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 blah. And then they said case control study. You know, no, excuse me, they said odds ratio in there. They embedded the word odds ratio. Then they said, what kind of study is this? And it was confusing. I mean, it was like, oh my God, where are they going with this? But the fact that they said odds ratio, you jump on case control, period. You see relative risk, you say cohort. No ifs, ands, or buts. Everything else is smoke and mirrors. They're trying to trick you, okay? Make those associations. Now, that's the meat and potatoes there. Where I'm going with this is a hard concept. And I did the same thing in Tampa. I said, guys, this is the hard part right here. Just know this when you win. Is that when you say odds ratio, there's a little formula that you need to kind of understand. But I said, look, learn it like this. When you're in Vegas, you start dealing with odds, right? And the odds of someone winning or odds of someone losing. It's one number compared to one number. The odds are 3 to 1, 2 to 1, whatever. But it's one number over one number. One number over one number. I'm going to divide it over. One number. All right, just see 1 to 1. Now, if I say relative risk, 1 number over 2. Just know that for right now. Once we see some questions, we'll start understanding where I'm going with it, okay? All right, so let me see, we got that, and let me see if I put a question early on now. Let's go over this, all right? This is real important. You got all those questions that you're going to get. It's not a matter of maybe you'll get them, it's a matter of how many you're going to get. That sensitivity, specificity, positive predictive value, negative predictive value. They're just going to flat out ask you. They're going to say, they're going to give you this chart, or they'll put things in words. And they'll say, what's the sensitivity of this study, specificity, blah, 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 blah. All right? So here's how we're going to understand it. Now I'm telling you, this works. It works every time. Okay? You got to understand, you got to be familiar with these little boxes, the 2x2 tables. We always call them Punnett squares in biology, but just call them 2x2 table. It's just the better term for them right now. You always want to put reality on top, okay? Top is reality, what's really happening in life, okay? Over here on the left side, you always put like the test. What are the tests saying, okay? And then you got to put positive, negative, positive, negative. You got to label them right, okay? You got to label them right. So, reality is on top, test is here, positive, negative. Now, if the test was positive, and in reality it was a positive, that is a true positive, right? The test was right, and in reality they had disease, and the test said they had disease. True positive. The test said they were negative, and in reality they were negative. Okay, well that's a true negative. Now here's where people get, the train jumps the track a little bit, okay? This is your take-home point, right here. Just remember, everything is based on the test. The guy took the class and said everything is based on the test. If the test was negative, but in reality, they had the disease. So that was a false negative. Everything's based on the disease. The conversation starts here. I'll say it again. The test said they didn't have it, but in reality, they did. So it was a false negative test, right? So they say false negative. That's where people mess up. That's where I mess up. When I was how do I do this? I always said, where do I put this? But it's all based on the test, and you never get it wrong. Okay? So, if the test said, yep, they're positive, but in reality they weren't, that's a false positive. You gotta know that. You gotta know how to label it. Okay? Pretty easy for the most part, once we go over it a couple times. So, here's where we go from there. Sensitivity. And here's our 4 things, right? Sensitivity, specificity, positive predictive value, negative predictive value. All right? Sensitivity, what does it do? It rules something out, right? That's like saying, this test is so sensitive. Like, I don't care if you're even close to being positive, it's going to find you. So if you're negative, you probably really don't have the disease because it's so sensitive, it rules things out, okay? Specificity rules it in. That's what in the first day they have that snout and spin is what they call it. Sensitivity rules out, specificity rules in. Just kind of keep that in the back of your head. All right, so here we go. We need formulas because they're going to give you a box with numbers in it, like I'm going to do here in a minute. And then you got to tell them sensitivity, specificity, and so on. So, we presented this before briefly. You're going to go like this. Sensitivity. I should have different colors. Specificity. And I'm going to go through this one. Now, all I'm doing is drawing arrows right now. Positive predictive value and negative predictive value. If you can draw something as simple like that, you know all the formulas. And you get them right on the test. So sensitivity, what did I do? I came up there and I circled, I had this box, and I circled this guy and went down. I went like this. So whatever you circle goes in the numerator, or the top number, okay? So what did I circle? True positive. This is sensitivity. True positive. And whatever you connect goes on the bottom. What did I connect? I connect this box to this box. I connected my true positive plus my false negative. Okay? All I did was connect those things. Whatever I circle goes on the top. Wherever I drew the line, those two boxes go on the bottom. It works every time. Okay? It works every time. For specificity, I went like this, here going up. And all I'm doing on this whole four-corner deal, I'm going this, and I'm going here, and I'm going here, and then I'm going there. Sensitivity, specificity, what did I circle? True, negative. What did I connect? True, negative, and false positive. So there's your formula for that one. The next one we did, positive predictive value. And what does that mean? That means when, the question is going to come to you like this. They say, you know, Ms. Jones comes in, says she has a positive test for blank. She wants to know, what's the likelihood of her test really being positive? Then you got to find the positive predictive value. You circled this guy and you go to your right. So what did I circle? True positive. What did I connect?
False positive.
True positive and false positive, right? Very true positive plus false positive. Boom. And then the last one. Negative predictive value. Ms. Jones comes in and has a negative test. She wants to know, well, what's the chance of my test really being negative? Find the negative predictive value. I go here, going this way. What's on my top? True negative. What's my bottom?
True negative.
True negative plus
False positive.
false negative. Boom. All right? There's your formulas. They will ask this. Guaranteed. 100%. 100%. But, you know, you can sit there and memorize things, or you can just draw this box. So, watch, we're going to do it again. Okay? Don't worry. It's all there. And again, this is one of those things when you catch me outside, you don't understand, you stop. We'll draw until you get it right. So on your test, when they ask you anything like this, they're probably going to give you a box. I don't care what they give. What's on top? Reality. What's on the side?
Test.
Test. You label it. Positive, negative, positive, negative. The test is positive. It's really positive. It's a negative. It's really negative. This is where our money comes in. It's all based on the test was negative, but the reality had it, so it's a false negative. Test is positive, but they really didn't have it. It's a false positive. All based on the test. Okay? Boom. We got that. Now, what do we do? Formula time. Sensitivity. I circle top left corner, go down. As a true positive or a true positive plus false negative. Specificity goes up as a true negative or a true negative plus false positive. Positive predictive value goes this way. True positive over true positive plus false positive. Okay? And then the last one, negative predictive value. I circle that guy, go that way. True negative plus false negative. Alright? That's it. Boom. Formulas are done. The only other formulas that you need to know for step one, the USMLE step one, you walk in the room, and as soon as the test starts, you turn over your paper and you write them down. There's like 3 of them. I'll show them to you in a second. Other than that, you know this, you get them all right. Okay? So here we go. Question 1. Well, for us, okay? Just trust me with these questions, they're valued. I usually come in here with different sets. This is equally to those other ones, okay? So, it says a new test to diagnose UTI, and this actually should be on the drive. When I sent it in, I actually put these on there for you. I didn't give you the answers, but I put them on there for you. All right? New test to diagnose UTI when it's being assessed. The comparison gold standard is a positive urine distance, blah, 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 blah. Results are given below. All right? They gave you a 2x2 table. What's the question? What's the test specificity? That's all they want to know. Everything else, smoke and mirrors, right? Specificity. What did we do? We did sensitivity, down, specificity, up, positive predictive value this way, negative predictive value that way. Boom. It's very quick, very easy. Specificity. What's my numerator? What's my top number? 180. What's my bottom number? 180 plus 20. So now I got 180 over 200. I simplify. I know. Not enough. All right, I got 180 over 200. I cancel out. Got 9 over 10. What's my percent? 90%. I'm telling you, you're gonna get a question that looks exactly like this. One thing different, they may change it to sensitivity. What's my sensitivity?
20%.
What goes on top?
40.
40. What's on the bottom?
40 plus 160.
40 plus 160, 200. What's my answer?
20%.
20%? Yep. Yeah, 40. Yeah, 40. 20, it was a 20, right? Right. Very good. Positive predictive value. What's on top? Remember, positive sensitivity, specificity, positive predictive value,
40.
negative predictive value. So what's 20?
40.
40. What's on the bottom?
40 plus 20.
40 plus 20, 60. So 40 over 60 is what?
40.
Roughly 66, right? 2/3, 66%. Boom. And that's it. I did so like that. I was like, I'm make it work. All right. But there you go. It was mainly just so we could work them out. So you're gonna get it. Guys, when I create my questions for next time, you think I'm gonna put at least 1 or 2 of these on mine? Yeah, you better believe I am. Because it's good stuff. It's value. You know, we can guess on a lot of subjects, but I can tell you almost with certainty, this is coming your way. Okay, it's coming your way. Got it? If you just know those formula things, piece of cake. Piece of cake. All right, here we go. It says a 5-year study is planned to assess the incidence of etiology of respiratory disease of 600 individuals greater than 50 years of age. All right? The study consists of 2 groups. One group cares for a pet dog, and the second group does not care for any animals in the household. At the onset of respiratory symptoms, cultures and serological studies will be performed. Which of the following best describe this study test? Okay. Now I put a lot of junk in there, but there's 2 tests that I want you to know, right? I want you to know case control or cohort. Okay. If you just take those away from this weekend, it's a victory because those are the ones that are coming now. So we got to ask ourselves, what's the difference between case control and cohort? Case control says, wait, A and an O, someone that when they did this study, somebody had the disease and somebody didn't. Case control. If it's a cohort, O and an O, nobody had the disease to start with, but they're looking at risk factors going forward. Which one best explains this one? And everything else to worry about. I want you to know case control versus cohort. They're looking at guys that are 50 years old, okay? Right? They said, hey guys, get some guys that are 50 years old. And then we're going to, when they did this study, we're going to look at the guys. Some of these guys are going to be ones that care for a pet, and then some guys don't care for a pet. It's exposure. So, the question becomes, did the guys have the disease or they didn't when they started this thing? They did not. All right, so if they did not have it, O and O is a cohort. Okay, and that's it. Okay, boom. Nothing else exciting about that. All right, you guys got to know the definitions. Case control, disease and no disease, and it's going to be obvious. Cohort, nobody's got it, and they're looking both ways on it. But then I said cohort. You say the word relative risk. If I said case control, you better say odds ratio. Gotta know. And I said, when you think odds, you're in Vegas. One number, it's an odds, 3 to 1, 2 to 1. One number up to one number. So case control, odds ratio. They're gonna say find the odds ratio of something. You gotta put one number over one number. One number over one number. Relative risk, one number over 2. All right. The more I say that, eventually it's gonna sink in, right? I couldn't think of any other way to kind of get that out there, but it works. It works. I had a friend. They texted me saying they were having some trouble studying, or they were doing well, and I was like, all right. It was the same time I was making these questions, so of course I screenshot this thing and sent it to them, and they got it right. That was kind of it made me feel good because I was like, all right, you learned. So first I was thinking, man, where'd you learn this? And they said, oh, from you. Danny, you taught me. I was like, gosh, you were there, you were there. So it made me feel good, all right? So it works, okay? And it's stuff you can retain. All right, here we go, boom. A new study to diagnose prostate cancer is being evaluated. The sensitivity of the test is 70%, and the specificity is 90. In the study, there are 100 patients who truly have UTIs and 200 who do not. How many false negatives are in this study? Now on the surface, you think, oh my God, are you kidding me? You know, we just learned this 5 minutes ago. You know, I didn't give you a chart, did I? No.
Sí, Daddy.
Now, the reason I didn't is just based on time. Otherwise, I would have put all those other 2x2 tables, and we would have worked those till we got sick of them. All right, and we will. But I want to keep going on to the next level because this is another way they're going to show you this question. But you turn it into a 2x2 table. Okay. Always tell yourself, what do I know? When you're totally lost, you say, what do I know? All right?
True positive.
Well, I know what a table is. I know when the top goes reality. I know when the side goes test. Negative, positive, all right? A new study diagnosed prostate cancer being evaluated. The sensitivity of the test is 70%. So what they're telling me is that this guy going down is 70%. All right. I can put that there. I can deal with that. The specificity is 90. Where's specificity? He's right here going up. He's 90%. In the study, there are 100 patients who truly have UTIs. So they're almost saying what? They truly have them. So in reality, they have them. How many? All right, so I know this whole column here adds up to 100. And 200 who truly do not. Well, heck, I got enough information now. I can answer everything.
Yeah.
I'm going to label my chart. Let's label it with what we know. Test is positive, reality is positive.
70.
Positive. Negative to negative, to negative. Now we make our money on these boxes right here. All based on the test. Test was negative. False negative. Test was positive. False positive. So let's think about this. If I got 100 people here, and something over that number, because they were nice enough to give it to me, makes 70%. So what number goes here that makes
70.
this over this equals
70.
70? What is it? 70. Then I can say, oh, okay.
I'm with Daddy.
So what number goes there? Yeah. You kind of go backwards a little bit. Now let's just keep going a little bit. This number is 200. Now, what makes this 90%? Don't get caught in the trap. What goes here? I know, you wish they would have used a better number, like 100. Yeah, 180. Very nice. Very nice. So what number goes here? 20. You gotta work backwards. But if you know that basic 2x2, they can give you this stuff. Guys, I didn't. I get this stuff from reliable. It's a good question. Okay, it's a good question. So this question said, how many false negatives are in this study? 30. You had to work way backwards on this, right? Now, they give you a 2x2 table, but what they gave you is enough information that if you know how to put these things in, you know, I don't care what they give. They can give me any number they want. I'll work backwards and I'll figure out what they want on this, okay? That's how it works. But you gotta be able to very quickly, on that test, is to work through these, and just know sensitivity, specificity, positive value, negative predictive value. There's all my formulas. I don't care what they give me. I'm gonna get it right. I guarantee I saw this. It's on step 1, it's on step 2. I'm going through the Q-Bank in step 3, it's on there too. And I'm hoping they give me the question, because I like it. All right? So, they could ask us anything, we got it. Answer C, we knew it. All right, boom, here we go. A test is being conducted to determine if older students have a lower score, less than 200, on USMLE step 1. All right? A group of older students, over 50, who took step 1 are compared to a group of younger students who took step 1. And data shown below. Blah, 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 blah. All right? I should have just went and put, that they had prostate cancer or something, something like that, make it a disease. But the fact is that we already know we got two groups already. Are they the same, or does one have something the other one doesn't?
Yeah.
Does one of them have something? Yeah, we know one got a high score or one got a low score. So we've already separated. One has a disease and one doesn't have a disease. What type of study is that? Case control. Boom. When I say case control, you say odds ratio. When I say odds, it's one number over, and if it's relative risk, it's one number over 2. Boom. So what's this answer? Case control. So then now we take the same question to the next level. It's case control, so we were going to say odds ratio. We weren't going to say relative risk ever. Okay? It's going to be given to you. What is the odds ratio? And when we read math problems, we read them top to bottom, left to right. Okay? It's the same stuff I told when I taught 4th grade. I said, guys, top to bottom, left to right. Here we go. What is the odds ratio relative to that of younger students, blah, 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 of older students having lower test scores? So I got to, again, top to bottom, left to right. What's the odds ratio? Okay, one number. All right. Older students having lower test scores compared to the younger ones. So who's going on top? The older person. Top to bottom, left to right. All right. This is what I mean. I know there's like a dead silence. All right. So top to bottom, left to right. So we said odds ratio. Odds, one number over one number. If that thing said relative risk, because if it was some other type of study, I'd be doing this. All right? But they say odds ratio. I don't care about him. I care about him. Now, the next question is, this is where you make the money. Who goes on top and who goes on bottom? I can guarantee you both answers will be sitting there. Answer choice A is probably the wrong one. All right? I don't know that on this one, but that's usually how it works. So, the question said, what is the odds ratio of older students compared to? So who's going on top? The older. So what are my two numbers?
60.
Okay. That's it. That's it. If it was relative risk, I'd go 60 over 260. But it's not. It's odds ratio. One number over one number. Boom. Divided by the younger guy. All right? That's it. It's coming. Oh, I gave it to you, man. I thought it was a decimal. Ah! All right. So what's our answer on this one? Yeah, C. All right? Know this. Odds ratio. Odds ratio. One number compared to one number. Relative risk, one number over 2. They're going to give you a chart. They're going to, on something like this, they're going to, did I mess up? You're going to call me out right now.
No, I'm trying to get it straight to it myself. You said the answer was C, but
Oh, that's the wrong one?
Yeah.
Did I put the wrong one on here? Did I not do this right?
Because over there, you have 60 over 200 divided by 40 over 160, and over there, that says 60 over 120.
That's my fault. That's 100% my fault. I made these, unfortunately. You can tell by the design.
No, I wasn't trying to call you.
Very good. That was you passed the test. just making sure. You are correct. Yeah, that was just me trying. Yeah, I had trouble in this because I was like, how do I tell this a divide symbol? My computer wouldn't do it, so I put all these extra parentheses. Good catch. All right. But the take-home point: odds ratio. One number over one number. Now, if they would have said, what's the odds of a younger person having, you got to put this guy on top. Okay? That's just how they're going to do it. I've seen questions just like that. All right? That's where you make your money. You know who goes on top. Odds ratio, 1 to 1. Relative risk, 1 to 2. Boom. It will not get any harder than that in biostatistics. I promise you. That is the take-home point of them all, right there. Everything else, piece of cake. All right. We good? So far, so good? All right. Here we go. This other one too. I like this one. This is such good questions that come out of this. They give it to you in graph form and so on. And I think we broke the code on this, and it works every time. All right? It's like this. There's these charts. You're going to see these charts. And the moral of the story, at the end of the day, they start changing the cutoff point on these tests. They say, oh, we're going to change the cutoff on this test from 10 down to 8. And they're going to say, well, how does that affect sensitivity, specificity, all that garbage, right? I don't care what they ask. Very, 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 very simple, okay? You got to know this graph first, and then you just got to know A, B, and C, and all I'm going to care about, and listen to me here, all I care about is moving that center line to the left or to the right. You know that? You answer every question correct. And they're going to give you these things that say, again, well, they just might give you a graph and say, I'm moving this line here from C to A, or I'm going from A to C, or I'm dropping the cutoff of diabetes. It's no longer going to be 120. We're dropping it down to 118. So I know it goes from, if they didn't give me a graph, I say, oh, I got to visualize. I'm going from C to A. I'm moving down. Okay? That's all you got to know. So here we go. That's how you do it. So you got to know these basic graphs. And all we're doing now is turning our little 2x2 table into this. Now over to the far side are our true negatives, right? Over to our far right side, true positives. And we make our money on the other guys, okay? Here's how you, and I always messed up, so I can always forget who goes in the box. Here's how you remember. Everybody keeps their last name, okay? You're on this side, you keep your last name. So it's a false negative. If you're on that side, you keep your last name. You're a false positive. That's the hardest part of this right there. All right? But just remember, they keep their name. So, here's those lines again. All you have to do is, again, I'm either going to move it this way or I'm moving it this way. I'm either going to smash the false positive or I'm going to smash